and suddenly when you get some corner, no, you try to hold. The moment you hold open, you start swinging, no, there you start rotating. Am I right? You can try now. So you run and suddenly try to hold any object or any pole or any wall or some sort of door knob, anything that one. So you start rotating, no. So same thing happens here. Suppose there is a rigid body. It is on a surface, huh? Not on a it's on a surface. It is having a linear velocity v naught, and there is no anything, only linear velocity. So let this be this. As it is moving, I'll suddenly inch about point P. I'll make it inch. Suddenly inch. Sir, how suddenly inch it can be possible? Now I'm asking what is the angle of state? About what point it will rotate? About center of mass or about point? About point P. It will rotate about the inch. It is suddenly inched. Try to are you able to understand? Say like I think I'm unable to show it. So you do run. When you do run, so at least I'll give an example. A boy is there. So when he runs suddenly and he stretches his arm, when he's running, suddenly if he holds pole, what will happen to him? Will he climb up the pole? No, no. He will start trying to rotate about the pole. No. I think there's a very natural thing which you might have encountered. Suddenly injured concept. You do run and stretch your arm. I think I can. Where is the video? Oh. No. You are running. Suddenly, when you hold it, you'll start rotating. No, like this. Actually in classroom. I could have shown well because as I run and suddenly hold the door, I'll start rotating. Anything you can do run. You do run and suddenly hold it. Hold it. What happen? Either a wall or any some so like a any like a fixed object. You hold it. No, you'll start rotating about that fixed object. So if I'm running like this, if suddenly somebody holds my hand, what will happen to me? I'll start rotating, no, about that particular point. So that's called like a suddenly inch. Suddenly inch is, inch is possible. So don't again imagine something big. You do run, stretch your arm, and hold a pole. You'll start rotating. Okay, now how to get this angular velocity? So there's a disk of mass m and radius r. Suddenly when you inch your pen, there'll be definitely impulse will act. So let me apply the angular impulse, angular momentum about this particular point. Sorry, my kid has come. I had to send him out. No. LPZI equal to LPZF. What is the initial angular momentum? Only translation MV naught R. What is the rotational motion? 0. Finally, what pen? Only rotational motion IP omega. So MV naught R is equal to what is moment of inertia? IO plus IC plus MR square by 2. Now what is IC? IC will be, now please try to understand one problem is enough. You can solve anything. Omega is equal to, this will be 2V naught by M get cancels, 3R. Now what is this moment of inertia? Why about point P? Sir, why not about center of mass? Yes, some impulse will act, no? That impulse, what it will do? You can't consider angular momentum. So what all that impulse acting about point P? So if the axis of rotation passes through point P, what all that impulse acting will intersect axis of rotation? So the net angular impulse will be 0. But sir, what is this omega we are not getting? And what you're writing, why don't you write only IC omega? Why you're writing IP? The moment you inject about what point it will rotate about axis passing through point P. Then what is moment of inertia about this point? Parallax theorem, IC plus mr square. What is IC? Mr square by 2. This is the angular velocity. There's a one very fundamental basic problem. Sir, if it is having both rotational translation, let it be. I'll bring next one. So I'm going to inch it. About any point I can inch. Now look at, see this. There's a suddenly inched. The disk is suddenly inched about point P. No, what to do? I brought omega also. What is this omega? Some of you are, let me write symbols also, so that will be very easy for you. No, it will have only omega. It will become fixed axis rotation. Conservation of angular momentum. LPZI equal to LPZF, initial angular momentum. Due to translative motion, MVCR, IC omega. Then finally it will have only rotational motion, IPZ into omega. All are clockwise. So MVCR, MR square by 2 omega. This should be MR square by 2 plus MR square. I'll write or one step. IC plus MR square. This is omega C. If he says VC equal to RC omega, write it. Or else express in terms of omega in terms of VC RC. Let me put a condition, let VC equal to R omega C. Then solve for omega. So this will be M 2M VC by R equal to MR square by 2 and this will be MR gets eliminated. 3 VC is equal to 3 let's look at the energy aspect here. Anything will happen to energy. Let's see, because we didn't bother about energy. So let me focus on energy also. Suddenly injured, anything will happen to energy.
Sir, shouldn't it be MVC R by 2, sir?
Yeah. This is 2 here. So how much we're going to get? 3 VC by 2, 3 VC, omega equal to VC by R. Check one's calculation. Okay, I'm fine. One by two. Yeah, fine. Now, let's get into the energy aspect. Anything will happen due to initial kinetic energy. So this is a disk MR square by 2 Vc by r whole square. So 1 by 4, 1 by 2. So 3 by 4 mvc square. Final contingency, only rotational contingency about point P. Moment of inertia already we know 3 mr square by 2. Final contingency will be Ip z omega square by 2 half into 3 mr square by 2. Omega is Vc by r whole square. Check one's calculation. Okay, this much. So no loss in contingency, you know. Is it really happens? This what in this particular situation. Let's go for the previous problem. We can't. Can we generalize or not? We'll check it. Huh? Can we generalize or not? We'll check it. Yeah, this one. What is the initial contingency of system? mv naught square. Final contingency will be half into ip omega square. Half into there's a disk, no? So this will be 3m r square by 2. Omega is 2 v naught by 3r whole square. mv naught square by 3. Now which will be greater? Ki will be greater than kf. So there's a loss in contingency. So loss in contingency. In advance, they will stress you this one also. You have to be careful. Delta k, ki minus kf. There's a loss in contingency of the system. It has come due to in what pen. There's a loss. Okay, now look at this. It all depends upon the situation. I think I did all calculations properly. MVCR mr square by 2 IC plus mr square omega. So MVCR VC equal to R omega C. Okay, till here no problem. Yeah, then initial contingency plus rotational contingency mv square plus r phi 1 by 4 plus 1 by 2 3 by 4. Finally ipz half into 3 mv square. Now look at, so can we generalize? There must be, or maybe. It all depends on situation. So we can't anything put like it should happen that one. So in advance, what possibility of asking like this energy aspect also. You have to be extra alert. And this suddenly hinged, not only disk, you can take any rigid body, suddenly hinged, then about that hinge, what it will rotate. Only rotational motion and suddenly hinge. This about only translative, rotative, both we took it. So what is the state of the disc? The disc will be like this, rotating and moving. And suddenly when you hinge it, no, will rotate like this, about this point. After some time where the disc will come here to this position. So earlier what is the state of it? It will be like this. The moment it comes here, it starts rotating after some time here, after some time here. I think best thing you run and suddenly hold a pole, you start running, or suddenly you run and if you get a corner, I think you'll try to hold a corner to make a turn, no? Nothing but the same sequence here. I think tomorrow again we'll continue. I do have plenty of numericals. Tomorrow we'll focus on Pathfinder, some good questions with springs all are there. Tomorrow we'll discuss some very good questions are there. Okay, thank all of you.
Thank you, sir.
Thank you, sir.
Thank you, sir.